Then we have used this prop case. As you saw earlier, this prop case is used to ensure that every word's first letter is capitalized. So for example, this is a new word, but its first letter is not capitalized. This will ensure that every word has first letter capitalized. Then this compress function I have used to eliminate the embedded spaces that I had in my product ID values. By default, compress eliminates spaces that you have in your substring values or the argument that you are passing. In case if you have some other character and not a space, then that can be specified and eliminated. For example, instead of spaces, let's say I have my product ID values as 21 star 02 star 002 star 0003 and I want to remove star. In that particular case, you'll have to specify compress in this particular format. So you need to say product ID is equal to compress product ID, and then you'll have to pass the second argument, which is star. So this will locate all the stars and replace them by, this will remove stars and ensure that all your numbers appears as contiguous or continuous numbers. Let's execute this data strip and see the output. Let's proc print. The name of the dataset is cleaned. We need to correct this product ID. There is no star, it's a space. So as you see, the spaces are not compressed just because you specified star. When you specify the second argument, then by default the elimination of space will not happen, will not occur. Proc print this. So if you see, product ID values are written correctly to my output data set. These are my product values. These are my order ID. Now if you see the problems that were there in product, where certain words had the first letter in small case, that has been rectified. Then my number 2 has been replaced by 5. So I see almost all my requirements are met, except one deviation that I see, that when I replace Lucy by Lucky, the space which was there after Lucy is gone and this is appearing as one word. So do one thing, you locate Lucy space and replace that by Lucky space, or you can remove this space and write only Lucy so that space is preserved. So as you see, now I'm getting the correct output. So my problem, the first problem where we had that number 2 got replaced by 5. Then the second problem where we had Lucy got replaced by Lucky. Third problem was we had this mittens M small case that has been rectified now. Now it's in proper case. And the fourth problem was we had embedded spaces in this product ID numbers that has been eliminated. And in this particular demonstration, we have implemented these 4 to 5 functions, that is find, transword, prop case, compress and substr. So hope you are clear and comfortable with these functions. So to quickly summarize them again, find is used to find some substring in a given string. Transword is a replacement function by which you can locate something and replace that by a new string. Prop case is a case function which will ensure that the first letter of every word is capitalized. Compress is to eliminate some special characters or spaces that you have in between your string values or substring values. And substr is, in this particular context, is used as a replacement function where we located a value at some particular position and replace that by a new value. In our next objective, we are going to introduce some more functions. So two major functions are introduced in the next scenario, which is scan. So like find function, we have a function called as scan, and then we have cat family functions like we have catx, then we have cates, then we have cat t and cat, and along with this we also have, so all these functions are basically to concatenate strings in SAS. Along with this we also have something called as this concatenation operator, where you can have this two exclamation signs or two continuous or broken pipes. This particular symbol. Now let's try creating a scenario based on these two major functions, scan and this cat family functions. So scan, as I said, is somewhat similar to find function. Find was searching your substring and returning an integer value representing the occurrence of the first letter of that particular substring. Scan function is used to scan a phrase or a statement by word. So in case if you have a phrase or a statement, say hello, how are you, and if you want to locate, let's say, a word you, then this is the fourth word in this particular given phrase. So that can be easily retrieved with the help of scan function. Let's quickly see a dummy example on scan function before we demonstrate it in our actual demonstration. So I say data try scan. Let's comment these function names, and here I say try scan. I say x is equal to hello, how are you, and then I say y is equal to scan x, and I say 4. Then I say run. Let me execute this. So we say proc print data is equal to try scan, and then run. So as you see, in variable y, this particular word u is stored. So when I say x comma 4, that's an instruction to SAS that you locate this variable x, that is the value of this variable x, and from that particular variable extract the fourth word or the word which is appearing at position 4. So if you see in this hello, how are you, the fourth word is you. This is the first word, this is the second word, this is the third word, and this is the fourth word. So scan locates or searches a particular value based on the word position. Concatenate functions are simple to implement. They are simply to concatenate multiple values that you have. So if you have your first name stored in one variable, and if you have your last name stored in another variable, and if you want to club them together and write it into one as say full name, then these functions can be used for that particular scenario. Okay, let's see a demonstration, a proper demonstration on this now. So we have a data set called as contacts that we are going to use for our next demonstration. So I say data. Let me see what kind of values I have in this first. I say proc print data is equal to contacts, and then I say run. This is Orion.contacts. So if you see in this Orion.contacts, we have several variables. We have something called as ID, then we have title, we have name, we have address 1 and address 2. Now let's say we are asked to work out on this particular data set and create certain variables which are suitable for mailing labels that is required by one of the business scenario. So I want to create a new data set where I want to write these variables in such a way that those variable values can directly be used as mailing labels. For example, if you see this title and name, I want to work on these title and name variables and ensure that I create a new variable by the name full name, where I have title, first name as well as last name. If you see the name values, they are stored in this US format where you see last name and then comma and first name. I want to rearrange these values and I want them in Indian format where we write mostly the first name and then followed by the last name. So I want this Sue here and far after Sue. I want this K be first and then Cox, which is representing the surname. So I want to create variables, a variable which has values like Miss Sue Fa, and then I have Dr. K B Cox. Those are the kind of values that I want to create in my output data set. So first I'm going to use scan function, by which I'm going to rearrange these values. I'm going to create two new variables where I'm going to fetch the second word and store that as say first name, and then fetch the first word and store that as last name. I already have title in another variable, so I'll have title, first name and last name that I'm going to combine with the help of my concatenation functions. So let's see how to do this. So I say data, mailing label, I say set Orion.contacts, then I say fname. Let's say in this variable I want to store first name as well as the middle name. So I say fm name, that is first middle name, is equal to scan. What was the name of the variable? Let me just check it quickly. So this variable name was name. So I say scan name, scan the second value, second word. So search name variable which I assume that has multiple words, and fetch me the second word. How it is going to understand that this is first word or this is second word and third word and so on? It is going to understand that with the help of the default delimiter, which is space or comma. In this case we have a comma, but even if you have a space, it will understand that as your, so whatever appears after that, it will consider that as a new word. So I want to create this variable fm name where I want to store first and middle name. I can instruct explicitly to my scan function that you use comma as the delimiter. In case if you want to avoid the default space delimiter, which I can see after, if you see the second name, this k and b both I want to store as first middle name in one single variable, and I don't want this space to be considered as a delimiter. I want only comma to be considered as a delimiter. Comma and space both are default, but if you write one, then SAS assumes that you want to consider only that character as a delimiter. So I say fm name is equal to scan and then name comma 2 comma and then this comma in inverted quotes. Similarly, I say last name is equal to scan and then I say name comma 1 comma and then in inverted quotes you specify comma delimiter. This is going to give me two variables, first middle name and L name. I already have title. I can club all these three and create a full name variable. So I can say here now full name is equal to catx. There are several cat family functions, but this is something which is used very frequently, catx, because this is the only function where you have an option of specifying a separator when you are combining several values. So when you use catx, there are multiple arguments that we pass. The first argument is something that represents the separator that you want between those multiple values that you are combining into one. So I say full name is equal to catx and then I write a space in quotes and then I say title. So I want title to be combined with fm name and this combined with L name. So these are the arguments that I am passing, title, first name and last name. So it is going to read title, write a space, then fm name, write a space and then L name, and that entire thing is stored in a variable full name. Now I write a keep statement where I want to ensure that only these variables are written to my output data set. So ID and then say address to. I want to write only ID and address to, and also full name that I created by combining title, first name and last name. So I say keep ID, full name and address, and now I say run. I say proc print data is equal to mail label. That's the name of my output data set. Then I say run. And this is what we have created here. This variable was address to. So this is what we are getting. Or if you want, you can avoid this address too and write only ID and full name. So if you see, this is what we have created. These are the ID values, and this is how we transformed that name into full name, and along with first name, last name, we had also written this title. So title combined with first name combined with last name, and between these three words, title, first name and last name, we have written a space delimiter. In second name, we have title and we have first name as well as middle name, which is written as one word, and then followed by the last name. So this is the data set that we wanted to create in this particular scenario. So we have completely transformed the input data set and written it into a new format. So these are the character functions which are used very frequently in base SAS environment. Let's quickly summarize the functions that we have implemented. So we implemented some 3 demonstrations. In our first demonstration, we introduced Sebastian and length function. So we use Sebastian function to read a particular variable, a specified character, starting from specified character till some number of characters. So in this particular case, we read this account code and we specified a dynamic length, and we ensured that in every case it is fetching one character of that particular length compared with 2, and then we did further processing. So in this particular case, we use Sebastian and length, which returns the number of characters in a given argument. In our second demonstration, we introduced find, transword, prop case, compress, Sebastian, where transword and Sebastian were used for almost similar task, where we located a particular string and replaced that by another string. Prop case was to make it into proper case where the first letter is capitalized. Compress was to remove the embedded spaces that we had in product ID. So those were the reasons or tasks for which we use these character functions: find, transword, prop case, compress and Sebastian. Then in our last demonstration, we implemented these functions scan and catex. Using scan, we located some particular words in our phrase or statement, and using concatenate function catex, we combined those words into one, and we had written it to the output data set. So we created a mailing label data set in this case, where we wanted to have title first and then followed by first name and last name. So that we achieved with the help of the scan and this catex function. So that completes the functions of our character category, and shortly we are going to start the functions of the next category, that is numeric, followed by summary functions and conversion functions. Now we will see how to make use of the numeric functions. So that's the next category that we are implementing. So as we discussed earlier, we have 4 numeric functions. So we have something called as round, then we have ceil, we have floor and int. Let's see how to make use of these functions. So as you must have seen these functions in other applications as well, the concept remains exactly same. So round function is used to round off your numeric digit to the nearest places that you specify. Ceil is irrespective of what is the digit after decimal point, always rounding off to the upper integer. Floor is always rounding off to the lower integer, and int is simply truncate the integer portion from a given floating number. Let's see. Let's try to demonstrate it in a data step. So I say data test numeric functions. You can give any dataset name here. Suppose I have a variable, say x is equal to let's say there's a number 12.3568. Let's first see how round function works. So I have this number where I said x is equal to 12.3568. I say rx1. So this is my next variable where I want to store the result of the first rounding. So I'm saying round x1 or rx1. So this can be any name, any variable name. So rx1 is equal to, I say round, specify x, and then say x comma, I say here the second digit as say 0.1. Then I say rx2 is equal to round of x, and I say round of this to, let's say give me the say multiples of 5. Then I say rx3 is equal to round x, I want multiple of 0.5. Then I say rx4 is equal to round of x comma 0.25. I say run, execute this. Excuse me. Let's see what is written to our output data set. So I say proc print data is equal to test numeric functions. Then I say run, close this log, clear the log and execute this. So just see what is written. This was our original value. Then in our first rounding we said round, we passed x and then say comma 0.1. So that was an instruction to SAS that you round off the digit to, write only one digit after decimal point, and whatever digit comes that should be multiple of that 0.1. So if you see this 0.4 is multiple of 0.1. So show me one digit and that digit should be multiple of 0.1. Then I said, in my second instruction I said rx2 is equal to round, and then I said x comma 5. So whatever result it is going to create, it will ensure that that result is multiple of 5. So if you see in this particular range where we had the value 12.3568, we have two nearest multiple of 5, that is 10 and 15. But if you compare, if you see the distance of 12 from 10 and 15, it seems 10 is the closest value. That's the reason why it has returned this value 10. Then in our third round case we said x comma 0.5. Round off the number and ensure that the digit which comes after decimal point is a multiple of 0.5 or 50. So if you see our digit was 12.3568, so multiple of 0.50 or 5 closer to this particular number are 12 and 12.5. If you see, 0 is more distant to 35 than 0.15. So it was 12.0 or 12.5. 12.5 it seems is closer to 35. That's the reason why it has preferred displaying or rounding and returning 12.5. Then we said x comma 0.25. Now again, if you see the digits after decimal point, we have multiples of 25 as 25 and 50. And if you see, 50 is closer to this particular number than 25. That's the reason, 50 is more distant and 12.25 is more closer to 12.35 than 12.50. So 0.50 and 0.25 are two multiples of 0.25 and 0.25 is closer to 12.35. That's the reason why it is displaying 12.25. So this is how the rounding concept works in SAS environment. If you just write, say Rx5 is equal to round, and I just say 12.3568, or maybe I just said x. If I execute this, this is returning 12. So if you don't specify the second argument, it won't display any digit after decimal point. It will simply round off your number and display the whole number. This is the concept of round in SAS. Now let's see the next numeric or integer function called as ceil. So we'll write a data step for that. We'll clear our log window. We'll clear the output window and say data let's name this as ceil floor int, where we are going to demonstrate all three functions. So in a single demonstration we are going to implement ceiling, floor and int. So suppose there is a number, say y is equal to 45.218, or instead of storing this number in a variable, we can directly print it. So I just say y is equal to, or maybe a is equal to, I say ceil of 3.9. Then I say AC is equal to ceil of 3.9. Then I say BC is equal to ceil of 3.1. Then I say C floor, just some random variable, CF is equal to floor of say 4.1, and then I say DF is equal to floor of 4.9, and then I say EI is equal to int of 5.7832. And then I say run. So if you see in first two statements within my data step, the first two statements where I created these variables AC and BC, that is A ceil and B ceil, I used applied ceiling function on this particular number 3.9 and 3.1. In third and fourth case, I applied floor function on this argument or number 4.1 and 4.9. And then in fifth case, I applied this end function on this number 5.7832. Irrespective of what is the digit after decimal point, ceil is always going to take the next integer. So it's not like round where if the digit after decimal point is greater than or equal to 0.5, it takes the next integer or else the previous integer. In this case, irrespective of the digit after decimal point, it's always going to take the upper integer. So in this case, it will return 4. In this case also, it will return 4. Whereas floor is exactly opposite of ceil. Irrespective of what is the digit after decimal point, it is always going to return the lower integer. So 4.1 will return 4 and 4.9 also will return 4. In fifth case, it is not going to bother only what is the digit after decimal point. It is simply going to extract this integer portion. So in first two cases, I am going to get my output as 4. In next two cases also I am going to get my output as 4, and in last case I am going to get my output as 5.